So my name is Michal. I joined VisualDNA in 2012, right at the beginning, so it's been 2 years, and I have seen the company to grow from, I'll skip from the stage roughly 3 years ago when when there were 10 people of us working around a single MySQL table with 50 million records in it, and basically scrambling for performance and scalability and all that. So it was essentially a LAMP architecture which gave us a lot of scalability issues. Not to say that you cannot scale with LAMP, but we all know that. So we anyway made the decision to go big data, which brought us roughly halfway through since 3 years ago, 18 months ago. We grew the team into the 30 members. Again, half of it were tech. And the architecture was still batch, but instead of MySQL, we had Cassandra and Hadoop. Hadoop to crunch it, Cassandra to store the output, and various batch processes that then pulled it off the Cassandra and to the platforms to whom we sold the segments. One interesting thing, we were one of the first commercial implementations and deployments of Cassandra clusters, which means it was terribly unstable, and we kind of helped Cassandra at the same time to evolve to what it is today, which is slightly more stable. It's still not completely perfect, but today our stack is from LAMP. This is roughly 1 year since the stage I described above. This is our stack of languages and infrastructure. Do you know what R is? So R is not completely built into the real-time infrastructure, but it's used for intelligence, loading the data sets, outputs, validations, feeding back to the process, and then it's implemented in Scala, typically. Java for infrastructure. It's an interesting combination of Java and Scala, which you can actually combine into a single project, but I'm not going to talk about that. Java is very good for infrastructure software, Scala good for modeling, at least our experience, because Scala hasn't matured yet in terms of connectivity and all the libraries that are available. So that's why we use Java for most straightforward stuff, I would say, connectivity infrastructure, and Scala for implementing the models. Hadoop Cassandra stayed as we were. Kafka, we introduced last year to bridge over from pure batch processing to more streaming, and actually, as you will see, it turned into roughly this. We have auto-scaling geolocated tracker clusters that harvest all the events from the pixels that we deploy. It's almost auto-scaling. It's not completely auto-scaling, but it's very close. From where we stream all the local Kafka clusters on those trackers. We stream through mirroring to our central aggregated stream, and that is roughly at the moment 8K events per second at peak, 4 or 5 at nights. Since we are still more Europe-centric and some US data, so we have a nice curve. We use this real-time infrastructure that is the aggregated and central streams for real-time product scoring services, integrations with third parties where it is possible. So that is the end where we sell, after we have computed all the segments, we sometimes in real time push them, but most of them accept just uploads, so that is still batch. ETL pipeline, simple thing, lots of Hadoop scripts. Lots of Hadoop scripts pre-computing views that are then used in different models. It is important because Hadoop is slow. It is a very important piece of infrastructure, but it's slow. It pays for the lots of I/O it does kind of redundantly and unnecessarily between the different nodes where it transports the data. So most of the time in Hadoop is actually spent transporting buckets of data for the processing, and therefore we had to approach it with ETL pipeline. So we collect the requests for what kind of materialized views are needed in different parts of the pipeline, and then we compute them for use. Most of this data we keep for 90 days, some of the data forever, which is the measured data I'll talk about later. But we have roughly 30 terabytes of primary data, which then after all the modeling scripts, the daily batch that updates them, it triples them roughly with temporary data sets. We have after the ETL pipeline, the decision analytics pipeline, where all the models are implemented, kicks in, which is today I think it's 100% scalding Scala. It used to be PHP wrapped into Hadoop scripts to begin with, but this is we're still on Cassandra in just a bigger one and more stable, 16 nodes, 250 megabytes active user profiles, so there's no megabytes, it's instances. And we have a sort of a Lambda architecture for where it makes sense, and that is for products like Y Analytics, where customers who place their pixel on the website can immediately see who is arriving to their website based on all our profiles, which you can have a run through the bullets later. I think I don't need to, but we have something that reads enrichment service that reads all the Cassandra profiles and attaches them to all the event tracking events that flow to us from the tracking clusters. So there's a little bit more about it. We are now 120 people. Again, half of it is tech. This is the team structure roughly we have. Sysadmin team, the smallest, architecture, medium, decision analytics, probably the biggest, where maybe consumer team is quite also, but the Y analytics used to be very big. I would maybe show the product, but you can have a look at visualdna.com/y. That is the front end on the Lambda, which visualizes in a pretty way with AngularJS the data that is enriched from the serving layer behind the analytics pipeline. I've added this here because at the place where we are, we found some things that I would like to share with you, which we have learned, which are about architecture, engineering, and process. And in terms of architecture, if you are using NoSQL storages, storing a JSON or any other format nested inside the column, which you have to read before you write it again when you update it, is a bad idea. It's not gonna work at some point. So the logging principle is probably in the world where you're streaming and processing incremental data sets, and typically your window of data is moving 90 days or something like that. Logging, so one type of components only write and other components only read. Read and write, very bad. Metrics are crucial in large distributed systems. This is more in relation to lots of test-driven development vibe that is happening. Test-driven is nice, but without metrics and without monitoring, and ideally with the feedback loops that correct the behavior of the system, without it you can't go. Basically, you're going to get failures, and then there's going to be arguments who failed, which unit test was bad. All of them are mostly bad. Unit tests cover typically the positive side of what can happen. Very rarely people test for things that they don't expect, so metrics and monitoring. Real-time processing of data streams is not only cool and nice pieces of technologies, but also scales well, more predictably. Not so much, it doesn't scale better, but it scales more predictably. You know, if you have certain throughput and you can nicely measure what can flow through the system, you know what you can expect. Whereas with the batch jobs, which often encapsulate orders of complexity, which you cannot just few hundred million users extra, and you will have 20-fold processing, and that's why our old pipeline of computation, sometimes a daily pipeline, took 30 hours or more, which means we are falling behind. And it's much more predictive. It's a little bit more difficult in a streaming world, but once you have something, you know you can rely on it and you can nicely measure it where you are. But the batch still matters, because lots of the valuable information that is extracted is typically a long-term characteristic of some population or groups of users. So batch is necessary to really have the batch layer as if we were in a Lambda architecture again. You've got the flowing stream of the primary events, but then something captures them, offloads them, crunches them on a daily basis as a large, let's say, like in our case, 90 days wide window, but you need it. The only thing is that there is lots of space for better technologies than Hadoop, like Spark, for example, these days. Scala in-memory distributed MapReduce framework from some university, I can't remember which one it came from. It's still not big, but it's already used. We have some companies, we know companies that use them in production. We use it only in research. But until we have Hadoop, we have to resort to coordinated ETL pipelines. So, in terms of engineering, this is my personal favorite. The Unix philosophy of building short, simple, clear, modular, and extendable code applies also to large distributed systems, not just OS that runs in a single computer. It actually applies even more, I would say, than in OS, but I have never coded on OS, so I'm not going to judge that. Here is the universe of the metrics and monitoring. Bad tests are better than no tests, but they are still bad, and most tests only test positive outcome. Just 2 days ago, we had whilst I was here, we had a very interesting problem with the Java math absolute function, which actually returns one negative, just one case. I'm gonna tease you. It's a integer minimum value because it uses the odd bit at the end. There is no positive counterpart of. So in the Java docs, you will actually find, sorry, the apps will return the same value if it's this value. And so we had an unfortunate user whose UID was exactly this number, and it crashed all our actually a third of our streaming infrastructure, because the partitioner that decides how to spray the data into the streams was returning a negative partition. It was just stopping. And it took us really a whole day, 3 of us remotely collaborating until we actually found that it was so we had to put one if. If the is minimum, then use the maximum. So none of the unit tests, we had kind of fair amount of unit tests and functional tests in our systems. Obviously, nobody would expect that apps can return negative, and again, that's the trap of relying just on test-driven tests. And in terms of process, it is possible to cooperate remotely even on complex systems and complex parts of infrastructure, as well as not defined. It's just a matter of resources, having a good use of things like Jira, wikis, have a clear communication is essential, but it can be done. So that's why we are actually moving to Bratislava, which I'm gonna, not moving all, but we are extending to Bratislava, trying to build a team here. And QA is intrinsic to architecture and local to products. So what I mean by that is that there is no separate function of QA, especially in infrastructure and architecture. It has to be built in, and ideally, it shouldn't. My ideal is not to have even a staging environment and development environment. There's just one production environment which works and tests itself that it works, gives you feedback, doesn't allow you to deploy things that don't work and things like that. So that's why it's intrinsic. And local to products is that there is no, we've learned that we've tried to have a QA for the whole company, for all the products, but they become such a bottleneck. They did their job. They were checking that the releases are not going unless they are tested, but testing took hours and hours and more, it just became a bottleneck. So they are local to products, and now we have a QA functions within each team or product that is happening, and that seems to work. This is, so I jumped from where we are today, and now what we are facing, and this is the 6. There are more. I think I've listed the ones that I could think of that are the biggest, which is that we have now clients in the financial industry, and there's a pressure for us to provide SLAs. And because everything in our system was built within 18 months, really, how it is now, so all the legacy was rewritten, it is not exactly 5 nines, and we have to give something. So we are thinking about separating the process and the architecture for those that have to be reliable, at least at 3 nines or 4, and the ones that we want to preserve also the dynamics of development and new products coming quickly to existence. So this is one of the issues that we're facing. The other one is that we now need to make our Cassandra or something else, basically our database of profiles globally available in real time, on demand. Meaning someone can tap into our database of profiles and act in real time before the user sees their first page, who they are, what the profile is, and do all kinds of personalization, recommendations, linking with other segmenting technologies and analytics. The third, our beautiful Lambda has massive bottleneck in the enrichment point, where all these 8K of events per second that are coming in, we read from Cassandra again for each of them profile, attach big map of tags. It's a bottleneck because our Cassandra is 16-node cluster. Even if it was 50-node cluster, it probably wouldn't work. What we need to do is come up with maybe global Cassandra, which we have had in our company Netflix guest who described us how they did global Cassandra deployment and how it works. Is one of the options, maybe some sort of caching, but we have to basically push the segments into the edge nodes where they're available in the API. That's another interesting thing we are facing. Complex data pooling attribution, I'm not going to talk about it. It's an interesting one, but Cassandra still gives us pain. If the drivers, there are many drivers, and none of them behave exactly same, because there are just principles by which Cassandra shares the replicas and by which it makes it available for reading and writing. So there are some interesting consistency debates, which you can look at the link if you will see this PDF again. And preserving the startup dynamics and the culture in a company of more than 200 people, which we are planning to increase to this year, with offices in several cities, is an important one, because we are still startup, even though we existed 6 years, I think. But the interesting things really started to happen, let's say, 3 years ago, and then it escalated to what it is now. And we like the culture. We think it's a good way of coming up with great ideas. But we are facing Moscow, Bratislava, and London team, which is one team. It's not a branch. It's not an affiliate. It's one team that works remotely, often meeting physically. So that's one of the biggest ones. And with our experience for who are we hiring from Slovakia and Poland, Romania, and all these regions, sometimes people are asking us whether we are here. It's one of the reasons. The other one is that it's halfway through between our Moscow and London office. So we are opening, we have a plan for opening a Bratislava office with 20 to 25 people. We're trying to hire engineers. So if you're looking for something interesting, want to work for London from Bratislava, we are here. I'm here. Tomas Červenka is here. Tomas Červenka. They stand at the bar there. You can meet us. Thank you. Any questions? Would you like to hear, for example, about any part of the architecture? Any question, business question, what regarding the office? Maybe if you're interested. Yeah, go on.
Mike? Yeah. Well, I can speak loudly. You were talking about pixels several times. What were you talking about?
About what?
You were talking about some pixels.
Pixels. Oh, yeah. Right.
What are those?
Those are literally GIF pixels, one by one, transparent one by one pixel that is attached. Normally it's generated by JavaScript, but in theory you can place it as a pixel into a web.
So web bugs, basically.
It points to our event tracking service. So whenever publisher partners with us, we give them a piece of code, which may be a pure HTML pixel, and it sends us, obviously, it helps us to cookie the users across the multiple websites.
I have two questions. You have one bullet that you are uploading every 5 minutes to S3. What you are uploading there?
So this was the architecture, the batch architecture 18 months ago, when the event trackers were just Apache logs. So again, the pixels were there. The they send URL HTTP requests to an Apache, and they were written into Apache logs, and we zip them and upload them to S3 for another later on download. So this was our aggregation pipeline, which we replaced with the streaming. So we were just zipping basically Apache logs and shipping them to S3, and then there was a distcp process that copied it to local HDFS in a data center. So this wasn't this one, it was this one.
Yes.
Yes.
Second one. Can you talk in more detail about that real-time processing? What is it? You know, some handler or some kind of pipe?
The real-time, so the streaming infrastructure, so it is basically based on a LinkedIn technology called Kafka, and it is a linearly scalable, truly linearly scalable streaming, call it queuing system, except it has a mixture of topic and a queue. So you have topics, but you register a consumer group which can consist of multiple processes, and then then only one of that consumer group receives it. So it's a mixture between queue and topic. It's a file-based system, so it uses low-level Linux. It relies on operating system to use page cache, so it just writes into files and makes them available in partitions. So as long as you have as many partitions you have, that is your parallelism. So all we have to do, for example, if we double the amount of events within a week, all we have to do is just plug more partitions, plug more boxes into the event trackers, plug more boxes into the center, so that we can mirror partition to partition. So it's Kafka. It's a very interesting piece of technology. If you're interested, look at it. It already has gone through second generation. There is Kafka 8 now, which we are still using Kafka 7, but already that works perfectly. And thanks to the mirroring, it's also very robust in the sense that there is one cluster in the event tracking zone somewhere in Amazon or some host cluster, and it aggregates all the messages in its local queue. And then we have a mirror process written in Java that consumes these topics and writes them into local, and also at the same time it repartitions them. So we use the mirroring also for partitioning and assigning topics, so we have more topics locally. And if there's a loss of connection, the events only aggregate in a local cluster, in a geolocated cluster, and when the connection is re-established, it will pull in, it will catch up and bring all the events in again, and it continues to flow. You can then subscribe, obviously, applications to it. Once all the aggregated events are in the streams, you can have real-time applications, you can have infrastructure, things like ETL tools that constantly listen on every new message and write them into the respective Hadoop file, for example. But then you can consume, you can react to clicks like the Y Analytics does it. It reacts to the clicks that happen anywhere in the world and increases counters in the Redis. So we use, for example, interesting combination is probabilistic counters. So you don't even need a storage. You just have a probabilistic counter for many dimensions that you want to measure, and then you make them available via API to the front end in JavaScript, and you can see literally who is coming to you now, your historical records. But yeah, Kafka is everything behind the streaming. Any other questions? Good, thank you.